Hello everyone, welcome to Software Engineering, and we're going to take a look today at Git and a quick recap of the basic Git commands we looked in the first lecture this week, and then extending our knowledge and experience of Git by looking at some lesser used commands, but commands that are incredibly useful, and dealing with real-world situations as well that crop up when we use Git as a revision control system. For example, merge requests that lead to merge conflicts. And these essentially occur where two people make two different changes on a branch. They conflict with each other, and Git doesn't know which way to resolve the merge conflict, and so it needs a little bit of help to get through that, and it will give you a couple of options to enable you to merge the desired choice out of those two merge conflicts and successfully merge the code that you want to merge. So this is a particularly difficult situation that we handle through merge conflicts, but let's just go back over the basics of what we looked at last time. We'll just zoom through the Git workflow again, just so you can see that in action with a new feature on our maths library. And we'll just quickly go over the creation of an issue, a branch, a merge request, and pulling those merge request changes into our local branch, and also resolving the issue back on GitLab. We looked at Git flow. We'll talk a little bit more about that today in our lecture. We've considered GitLab, which is equivalent to GitHub and Bitbucket very often. And we've looked at the basic Git commands of git pull, git push, and git commit. We're going to extend that now and look at more GitLab features that offer some more facilities for us in our collaborative software development environment, and also the concept of reverting a commit as well. We've seen in the Git workflow how to clone a repository, how to create a new branch, and we used git bash for that purpose, how to then make a change in our working directory, how to stage those changes, how to commit changes, push changes back to the remote repository, and then merge our branch in on GitLab. And the way we did that before was our command line tool, which you can see here, called git bash. And I'm just going to switch to my Bath University directory. This is my working directory and my maths library. And here it tells me that I'm on the main branch. I always do a git pull just to make sure that I have the latest changes, and you can see it's pulled down the latest changes that I made last time to the add to numbers functionality. We also, if you're not so comfortable with the command line, we also have the ability to edit all of this in VS Code. So you can open VS Code as a more fully featured editor, and that has some advantages over using the command line, and you may prefer to do that. The way you can do that is open a folder where your Git repository is checked out. So I'm just going to browse to that repository now and go to my user directory and go to my Bath University and then go to my maths library. And when I select a folder, it will ask me if I want to trust everything in this folder. Select yes to this option here, because we trust our own code in this case. And you'll see now I can add to the add to functions, add to numbers function. And I've also got my README document here as well that GitLab created yesterday's lecture when we first created the repository. So we can actually work here as well. There is a terminal option here. I can create a new terminal, and I can create that as a PowerShell or a git bash here as well. I can do a git bash in here, and you should see similar output to what you see on the Git terminal. So Git, if I do a git status, for example, it tells me that I'm on the main branch and that there's nothing to commit, and my working tree is clean. This is a more comfortable environment to work in for many. If you remember yesterday, I was on the command line using VI to edit my functions. That's good for small functions, but you might like the comfort of being able to work with multiple files at the same time, have one or more files open, and it's a more visual IDE and editor. And as you can see here, completely integrated with Git. If I made a change, I could actually use the integration of visual code with Git as well. So let's try that. Let's just make a small modification to the Markdown documentation. And by the way, Git tends to use Markdown as its main source of documentation. You don't tend to see Word documents and Excel files because of their proprietary binary format. Most documentation, I would say, in Git repositories is done with Markdown. And so it's worth learning Markdown as part of your Git tutorials, because this is the way we document our functions, our files, our release notes very often. And if you go to github.com and access a public repository, you'll often see a Markdown file called readme.md, which explains the project and what you can do and the APIs and other essential documentation you need to use that software. So Markdown is a very easy syntax to use. It's also great for Git because you can do diffs. If you do a diff of two Markdown files, it will show you the last revision compared to the current revision. And by the way, that's a command we haven't tried yet, so we'll show you that too. You can extend this and then do a diff to see what's changed much more easily. And this is why people who work with Git like it. It's very difficult to do a diff of Word documents or Excel files because of their binary format, and you cannot easily see the differences, but with Markdown you can. So here I could say, for example, my new maths library, and you can use 3 hashes for nested headers, 2 hashes for the second level of headers, and a single hash will give you the top level document description and header, usually a chapter header. So you can do that. Add to functions. This function adds 2 numbers together. And we've changed the file. We can save that file and we can do a git status again. And we can see now that we've modified readme.md. And you can also see this little source control here that Visual Code in this case has picked up in its integration with Git. So Visual Code has recognized that this is a Git repo and is offering us the ability now to update this file. And also, if you hover over this, you see the merge history for this file too, which is called the git blame, by the way. If you do a git blame on a file, you'll see who's edited it and what edits that they've been making. And we'll look at that in GitLab as well. But here we see this function has been merged, and I really love this integration. You can see side-by-side comparison. This was the previous version of the add 2 numbers function, the first version. Then we added these 3 lines. You see the plus here, that we've added this if statement. We've added the closing brace for this if statement. And then that was the first branch, and you can see the history as we go through of what we did last time. And it's really super convenient to do that in VS Code. We see now in this particular issue 2, and because of our naming convention, remember when we did the git commit message, we did git commit message 1, and that was related to issue 1. And then this one clearly relates to issue 2, where we decided to add some checks on our add function. And now you see graphically that we've gone through that part of Git, and then we merged back into the main branch, and you can see the history. Merged one create a C function branch, and with the description, it closes issue 1. So it successfully read a whole load of data from GitLab and from the issue, and it's even pointed us to the merge request. See the merge request, math library 1. And it's given us the commit ID. So really, in this convenient IDE, we've got the source code, we've got the git command line, we've got a visual overview of what's happened in this branch, who did what, we've got the blame, we've got all the details of our history. And then we've got details of the merge, the actual commit as well, and the commit message. And you can hover over those and click, and see what those messages are. And then in this case, we came back then to on another commit to, that was the first commit, and then this was the initial commit. So we go in reverse chronological, and the latest update was this one here, and you can see our 4 insertions and the commit ID. Wonderful, absolutely amazing. So it's offering now basically if everything I did on the git command line with git bash, I can also do here. So let me just write, so updated readme document, and I could commit it here. And it says there's no staged changes to commit. Would you like to stage all your changes and commit them directly? I could choose yes, always, never, or cancel. Now, what's this about? This is staged staged changes to a commit. I would here say yes, but not always, because sometimes I might want to continue working and then just do a git push right at the end of the process. So now it's gone ahead and it's updated the README document, and it's added that to my source control graph. And so I can see a nice clean history of events as we go. Now you can imagine this graph as you are working on your projects, and collaborating in a multi-person way, that this graph gets complicated, and you'll see different things happening. You'll see sometimes somebody jumps ahead, you check out a branch, but the head moves on because somebody else has merged. And so what do we do in that case? We do something called rebasing, where we essentially cut our branch and we reattach it to the head of main. And so rebasing is important when we get behind the main branch, the head of the main branch, and we need to reattach our branch to the latest changes. Essentially, we're pulling in the latest changes to our local branch, and that's rebasing. And that's a whole topic in itself. We could do a whole lecture just on rebasing. So, yep, really convenient. You can do this with a bash shell, you can do it with a git bash, and all looks really good here. So let's go back to GitLab itself, and well, let's just recap firstly the Git workflow. We've done the cloning, creating of a new branch, although in that case I just committed to the main branch directly. Again, I'd advise against doing that. Have a policy in your projects where you want to commit all your changes to a branch, and then raise a pull request or merge request to bring your changes into main. And the reason we do that is that quality control, somebody else getting a 4-eye review on your code changes. And then coupled with a DevOps pipeline, which we'll talk about in the future, that will give you a certainty or assurance that your changes are good and that you've made the right changes. So we've committed our changes both locally. That saves a snapshot of our work, creates a history of the changes to our files, and then we've pushed our changes to share those changes with others. We push them to the remote repository, and this then makes our changes available to other collaborators. It's fine to push regularly to the server, and in fact it's kind of recommended. The Git way of working is not to just work in isolation on your machine and save like 3 months of work that only you can see. But the kind of culture, if you like, is to commit early and often, maybe several commits a day, at least one commit at the end of a working day, so that you've pushed your changes to the repository, even if it's a work in progress. And I would suggest that if that's the case, I'll just do a git pull now on here. I would suggest that if you have a work in progress, that you your commit message has WIP in it somewhere. So if you go back to your git commit call here, instead of the issue number, just put a WIP here, work in progress. And then when you do your revisions, you know that maybe something's not working yet, but you're just staging your commits, you're pushing your commits in the intermediate state that they're in, and then you can continue tomorrow. Why do we do that? It's just good practice, really, a bit like saving a Word document as you go along. It's the best thing to do. It also is a record of what you've done in that day. And if you're a consultant, for example, on a project, always good to have evidence that you worked on that particular day and what you did on that day. And if you have a Git commit with a bunch of files that you've edited and changed, then that's good evidence of your work for that given day. And that's another reason why GitLab is so popular, is it stores our work, and you can also configure various actions based on the commit message. So if I have WIP or draft in the merge request, I can elect not to run a pipeline, not to merge the code. It just kind of is an indication of what kind of commit group is contained in this group of files. So that was the Git workflow. We've seen all of these introductory commands. I would encourage you to learn these kind of off by heart, get practicing. Git create is another really good command if you want to create another branch on the local repository. So I could do, for example, in here, I could do git create -b my new branch. Sorry, checkout, not create. Git checkout -b, and that will switch me to my new branch. But at the moment, it's only local, so the server doesn't yet know about my new branch. This gives me the opportunity to work completely locally on my new branch, do my local things, and then I could do a git push, and I would have to associate this branch here with the name my new branch on the server. So if I did a git push now, it probably wouldn't work unless it intelligently realized what I was trying to do. And indeed, you can see it doesn't know about my new branch on the server. There's no upstream branch called my new branch here. It's conveniently given me this command called set upstream, git push, and then set upstream origin my new branch. I could do that if I want to, and it will now go ahead and push my new branch up to GitLab. So if we flicked back to GitLab, you should see up here in our maths library, I now can go to, you see it's just noticed that I've pushed my new branch to GitLab, and it's offering me to create a merge request. Well, at the moment, I haven't made any changes in my new branch, so I don't need a merge request, but I have got that branch now on the server, and it's synchronized with my local branch as well. Okay, so let's go back. We've seen now how useful GitLab is generally, and this way of working. It's super productive. I personally love this link between issues, branches, merge requests, code, and just getting stuff done, basically. So going back to yesterday's session, we created two new issues, didn't we? We added checks. We created a C function to add two integers together. We then added data checks to the add function. I'm just going to quickly zoom through that process again and show you a couple of new things. So I'm going to create a new issue here. Create. I was going to say create a new function to subtract two numbers. Okay, and no description. I'm going to assign that to myself again, and I'm going to create the issue. Okay, so this is a function to subtract two numbers. This is issue number 3. You can see that in the link up here. And I'm going to create a merge request, and I can link issues together. There are some good reasons to do that. So linked issues are essentially bidirectional relationships that are possible to create between any two issues. And you can block one issue. You can say one issue has to be done first, so you can give it a prioritization. But that's a useful feature. Some of these features are not always available. GitLab has a free tier and a premium and an ultimate tier. So this one does happen to be available. So I'm going to create a new function to subtract two numbers, and I've assigned the issue to myself, my Neil Langmead Bath Uni handle, and I'm going to go ahead and create the merge request. And you'll see now this closes issue 3 once we're once we've resolved it, I'm going to assign the merge request to me as before, and I'm going to create that merge request now. And did I click the button? No, I didn't. So I'm going to create the merge request and just come back to Git. I'm going to get back to my main branch here. And now I'm ahead by one commit. Okay, so I can do a git pull because once I did that creation of the merge request, the head of main went on by one, and also because I did the push of the change to the README. Okay, so always do git pull, see where you are, make sure you're locally up to date, you're pulling in the latest. That means if one of your colleagues also updated main in the meantime, you'll get the benefit of their changes when you pull that in locally. So this is a great way to work when several of you are committing code, you're merging stuff, pull it all down so that you've got their latest changes. Here you see we've got a new branch for that issue we've just created, issue number 3, create a new function to subtract two numbers. But I'm still on the main branch, I haven't switched to it yet. Let's do this in Visual Code just to show that integration again. So here I am on main. I'm going to do a git pull, and it should, because I'm in the same directory, say that I'm up to date. It does, and I can do a git check it out, and if I do a tab, you can see the options already. And this again, if you have lots of different branches, this is a great option just to see what branch you want to check out. And because of the GitLab link to the issue, I just need to type the issue number 3 in this case, and then tab, and it will finish and autocomplete for me. And that's the other reason why it's good to link branches to the issue numbers. So I'm going to check out, switch to that branch, and you can see my source control window has kind of prepared that now. And this is the branch that I'm on. And I'm on this branch here. You can see the head of my source control graph is this 3 create a new minus function into this branch. Now what do I do? Well, I could add the function into add two numbers, or I could create a new file. So it kind of makes sense with the naming here to add a new file. I have a slight preference for VI, so I'm just going to drop down to here, and I'm going to do a git checkout again in this window, and I'm going to do a git pull. Just because I want to make absolutely sure I've got the latest from that branch as far as the server's concerned. And I'm going to do a VI now, subtract, subtract to numbers.c, subtract to numbers x int y. This is my amazing C code that I'm developing. Return x minus y. Okay, so let's do that. By the way, in a real kind of software project, you would check that you can actually compile this thing, and you install a GCC compiler or whatever. We'll come on to that later, just to validate the software before we actually commit. Do what we call a pre-flight build or pre-flight test. In fact, let me. I'll do that later. So we've got our subtract two numbers. Now you can see here, I've got this button here to stage the changes. I can discard changes. I can open the file, which I'll do anyway. And we should see subtract two numbers. This is the new version. The diff is not showing any previous because this file has just been newly created. So again, I prefer using the command line, so I'm just going to do a git add subtract two numbers, and I'm going to do a git commit again, and this time this is issue number 3, and added a subtract function. Added subtract to the library, and here we go with the git push again. Okay, so here's our git push, and you can see it's actually stored, it's given me the merge request, so it's called this merge request number 3. I could copy that merge request link up here and go to it here, probably, yep, and then I'm directly in the merge request as well. And You can see again, merge request is blocked because it's a draft. I've got various options here, but you can see the behavior now will be that this issue number 3 will be closed once we merge. So the other things we can do, we can review our changes. It's possible to add a comment here. It's also possible to start a review with certain editions of GitLab, not this one, this is the free version. But normally you can add, I think you can add a suggestion here. So let's say in the code review phase, you're reviewing your colleague's code. You're coming here and you say, I want to change this. It will give you a suggestion. And you could then put your suggestion, which might be in this case, add a code comment to document the function's purpose maybe. So you could say function to subtract 2 integer numbers. And that's my suggested change. And you could then, you can see this is also using Markdown. So 3 backticks with a suggestion in GitLab means an automatically applied suggestion. So when you add the comment here, then this is my suggested rewrite of that code. Then what you see is GitLab has taken that suggested change in the code review, and now we have the ability to apply that change automatically. So if I apply this, it would do a git push of this update for me. So this is a super quick way of collaborating with somebody, both of you in GitLab, doing a code review, write your suggested changes in there, and then it's easy for the author, if they're happy with that, just to apply the suggestion. So you can apply the suggestion, you can give it a commit message, great suggestion, and to add, so adding documentation to the function. And this also resolves the thread in this case. So you've opened a thread and you've now applied that suggestion. You can see that we've got a new line which basically provides a comment for the function. Now, what does that mean? So think about this. Our suggestion's been committed, and so that means the head has moved on in the merge request by 1. All threads are resolved. You can start another thread here that instead of having x minus y, let's do that. Let's put another suggestion in. And here, for example, we might want to do some more checking, that kind of thing. We could add, let me just do that a little bit better. Discard the changes. Actually, it's kind of here I want to do the change. Maybe it'll let me do that. Yeah, so instead of x and y, we're going to do z equals x minus y, and store that in a local variable and return z instead. Okay, so I'm going to add that as a suggestion. This is my suggested edit. So store first the x minus y in a variable, then return that variable. And I'm going to apply that suggestion or add it to a batch. I'm just going to apply it, and hopefully that will then be applied as well. So really easy to review code, make changes, add comments, add documentation. Use this feature, especially in your projects, because it shows that collaborative working together. Then what we could do is, you see our commits now. You can see that I've applied these suggestions. GitLab has managed that process in the commit for me. I've added documentation to the function. I've added the subtract function. So I've got 3 commits here. And remember, we want to squash commits and we want to edit the commit message. We just basically want to do that because we don't want 3 different commit messages for this branch to go into release notes. So we just tend to squash commits and summarize all of the things that have been done in multiple commits. This is our merge commit message. This is our squash commit message. This often relates to release code, release notes messages. We're setting to auto merge, and this is the commit message that basically summarizes kind of everything that's been done. And that's all we're going to do here. We're going to, oh yes, so the merge is blocked because we've got draft in the name. So we're going to mark that as ready. And now you can see we've also got a merge conflict. We've pushed the latest changes and all suggestions with that merge conflict. And we're going to review the changes and look at these changes now. And here we have a version which adds both the comment and the updated variable as well. All good. And I've actually noticed I didn't put the int declarator there in Z. I could go back and add that, make yet another commit. I could do that on the changes window. So if I just go back here, do my suggestion and just do int Z, that should be resolving this one. Okay, so that's my suggested change again, super easy. I'm going to apply that suggested change, resolve the thread here. That's been applied. And let's see our commits now. We have, see how many commits. We've got 4 commits. We're going to squash those commits. And it tells us we're ready to merge. So let's go. So let's merge that. And just before I do that, we've made some changes on the remote. So here, whenever we're in GitLab or on the remote branch, I could just synchronize my local version just to make sure that I've got all of that. So I'll just do a git pull and it will pull those local changes into my local branch. Why have I done that when I know the branch is going to get deleted anyway? It's just so that I've synchronized between the two. It's always a good idea. And now that the local version always matches the remote version. And that's a good thing to do if you're in a software project that's changing very frequently. So in this case, I'm going to merge. I've resolved that conflict that was in that file. I've also made some improvements in the code review phase, and this has now been merged. And you can see the commits hash here, which is always a group of numbers that look a little bit like this. You can see that's the commit hash, which closes issue number 3, and it was done in merge request number 3 as well. So that's the merge request, and that's the issue that it relates to. Just amazing for traceability. Connect the issue, which is usually the customer-facing, customer requirement bit. You would typically have, as we've talked about in software engineering before, you'd have a customer-facing Scrum leader that is kind of the interface between the dev team and the customer. That kind of person is ideal for creating all of the issues in GitLab to implement the new features, implement bug fixes, and do all of that kind of stuff. That's the essentials of Git. We can also do things like cherry pick. So we can take a commit from a particular branch that we like. So inside the maths library now, you can see, if you just go to the code, you can see all of the commits that have taken place on this particular project. And all of these have commit IDs here. So if we saw something in someone else's branch, maybe somebody patched a file in some other branch for this maths library, and we say, oh, I want that commit, we can cherry pick the Git commit from their branch into our branch rather than pulling everything in. And we need the ID here of the Git commit, and we'll show you the command line to do that. That's quite a useful feature. Don't use it very often, but it's quite useful. And also there's a command called git log, which basically shows me all of the changes that I've made and when I made them. Git log is a tremendously useful command. It kind of super useful for forensics, just seeing who did what when, seeing the development, the evolution of a file. Also, it contains a lot of data that we can use for machine learning and AI. So if those of you who are interested in creating models that would automatically fix things based on people's programming styles, you could analyze previous Git messages, train a model on people's working practices, look at where people, maybe Bob fixed a load of issues and you found the same issues in Mary's branch. And so you could actually learn how to fix things from Bob's branch and do the same in Mary's branch. Just an idea for those of you who are thinking about AI and how Git works with AI as well. So there we have it. We have git log. git cherry pick. We have our git merge request conflicts. Some other things that you can see in Git, we've seen the different branches. Now we have, so we have my new branch. That was the branch we just created with no changes. That's had no changes there. The main branch is the one we're protected. We don't want to allow anybody to check into code there. And so we can set branch rules, and that's the kind of rule that you want to set, is that main cannot be added to directly. It's protected here. People who are allowed to merge are the so-called maintainers. People who are allowed to push to a branch are also maintainers. And so you can set quite granular permissions on each user, actually, as to what they can do and what they're not allowed to do. And typically, your config manager would have permissions to do everything. Developers would have usually the permission to push to their own branches, and not much more than that in big projects is what I've seen. Okay, so there's repository settings. Then we also have a few other features. We've got the Git repository option itself, where you can actually see the actual files in this library repository. And if you look at history here, that essentially gives you the Git blame. You can copy the commit char, as it's called, and you can also think for any file that you have in the repository. You can actually download it, you can view it, and you can copy the file contents, you can open it raw, you can download it, and you can edit in place. I think we showed that yesterday, that you can also edit the any file in GitLab directly, and also in GitHub. So there's the branches, there's our commits. Our repository graph is quite useful, just to help see what's happening. There's not too much data here at the moment between our branches, but we can actually compare two branches, and it will give us the delta between our main branch and our new branch that we created. That's a nice feature, just to help debugging. Something works in that branch but not that branch. Do a comparison, and you can create a merge request directly from that comparison as well. Basically merging from the source to the target. And this is good for rebasing, for moving any changes from one branch to the head of another branch. There's also something called the repository graph, is what we saw in VS Code, pretty similar, where we have an interactive view of the commits, the time data, the information that happened, and basically the flow of commits and merges out. So you can see that my new branch is out on its own now. And actually that's a good point to talk about rebasing, because whilst I created that at the beginning of this lecture, I also incremented the head of main. So rebasing is essentially taking my new branch here and reattaching it to the top of main. Or what you could do is you could see it as pulling in the latest and greatest on main, and it's updating my new branch to the head of main. It's a little bit complicated. I can show you how to do that. You can basically, if I go back to main, it may not work for another reason I'll explain, but basically we are one commit ahead again. So I'm just going to pull the latest changes, and it's pulled out the latest changes of main. Let's check out. So locally I have the latest main. If you think about this graph here at the top, on the server, I have the head of main is further on than if I switched to my new branch. So if I now do git checkout my new branch, you'll see the problem, because my new branch is now behind, but my locally stored copy of main is ahead. Okay, so I need to do something called rebase. This may not work, but let's see if you can do git rebase -i, and you normally do origin to rebase on the origin, and you can see I can cherry pick a commit from that, because essentially what happened here, since we branched from my new branch, we only updated the README document here, and then we got to the new head. So it's found that commit here. We can actually do that, and it's successfully rebased and updated to my new branch. Okay, so now essentially what we've done is cut the head of my new branch and put it at the top of main, which is awesome. So rebasing is something we need to do often, particularly if we're working locally, other people are working on the project, they push ahead on the main branch, we want to pull in those changes to our local, and we do that through rebasing. This is the simplest use case of rebasing, where you have this situation right here. Awesome. Right, let's go to the slides. Let's just sort of attempt to wrap this up a little bit. We have seen how to git cherry pick, and here's an example of that, allowing us to apply specific commits from one branch to another without merging the entire branch. And the way we do that is we look at the git log, we see what the SHA of the commit is, the SHA of the commit is, and we then basically switch branches, so git switch, or I could do git checkout and do it that way. And then I cherry pick a particular commit SHA into my code base. If conflicts arise, then we can resolve that in the merge request conflict. I suggest using GitLab for merge request conflicts. VS Code is also pretty good because it gives you that visual view directly as well and enables you to resolve what's happening. This is also called backporting of bug fixes. Essentially, you backport a bug fix that's happened on a different branch to a production branch. So you've got your main production branch, somebody does a fix here or something, and you want to cherry pick that fix and put it into the main. This is the way to do that. A very, very useful feature of Git. So typically you'd have those commits on a feature branch, then you apply a particular commit to the main branch. And so use that as an example, switch to main first, then cherry pick a particular commit ID. These Git SHAs are unique for every project. So you can't, it will know what Git SHA to pick with the right number that you give on the commit hash. And then just looking at what happens in a merge conflict, this happens when Git can't automatically merge changes due to those overlapping edits. And what you tend to see is it's picked it's comparing a diff from the head. This is what the head is. This is what the content is from being merged, and they're different. Which way does it go? And it needs your help to resolve. And so you essentially just delete either the top bit and the lines at the bottom, or you delete the bottom bit and leave the lines at the top, depending on what you want to be in the final commit. So here in that scenario, you've done staging, you've done two commits, you've branched off from your staging to a feature branch that has two commits as well. But these are different commits to these commits, but on the same file and in the same space of the file. And so when you come to merge, it can't merge your changes on this feature branch because it has different changes on master compared, or the main branch, sorry, compared to the original branch when you did it from staging. So you'll see these conflict markers, these chevrons. Look for those in the git diff files. That's another command that kind of helps you just git diff, and you can just type that. In my case, no diffs, obviously, but that will give you the diffs between two different branches. And then once you've resolved your conflicts, add the conflicted file back to the repository, and then do a git commit and git push again to complete the merge. So you'll probably find these a few times, I think, in the project as you develop the code. Nothing to worry about. It's just happens. Two people working on the same file is the usual scenario where that happens. But it's easy to resolve, and just figure out between you which direction you want the merge to go in. Then we've seen git log displaying the commit history for a repository. Lots of data, as I said, contained, including frequency, committers, names, file changes. Perfect data source for a RAG database on an AI engine, but that's a topic for another day, as I said. Git log was the command that we used, but you can actually have a condensed view. So git log --one line would give you the history of basically the commit logs and the what happened with the merge requests and the initial commits and the commit messages. There's also git log --author equals, so I could do a git log --author equals, let's just go Neil Langmead, and it will just search for my own git logs. That's another useful thing, just to filter some of the data. These git logs can be pretty big, so using that as a filter makes sense. Limit the number of commits, so git log -n5, you could do git log -n5 will show you the last 5 commits. Again, it's just a summary information. And git log -p shows the code changes within the git log as well. Okay, so here it shows that I added those descriptors in the readme.md file right at the beginning of this lecture. So that's git log. Git revert is also very useful. This will safely undo changes. So imagine that I've done a git commit, I've done a git push. Now I want to revert that change because of a conflict maybe. So you're on the main or master branch here. You've got your feature branch that's branched off it. That has a few commits and you fix something. But you merge something in from the feature branch, but then you fix something else on the feature branch. So you haven't deleted the feature branch at this point, but somebody else has done something else to fix something. You've still got that branch locally and on the remote server. How do we merge everything back to the master branch here? Well, we would revert the commit. Okay, so we revert that commit back. We open the editor to confirm that commit message, a bit like the git rebase that we've just done. And then we can log the output, and then we revert that buggy feature to get back to the state that we want to. So this is a way of safely undoing without rewriting history. So git reset is the other option, but that has the disadvantage of rewriting history and eliminating the history. So you can't see what has gone because everything gets wiped. Whereas git revert, you preserve history. So it's a safer command. If reverting causes conflicts, resolve them as you would with merge conflicts as well. So that's our advice there. And then best practices, as I say, write clear commit messages, less than 80 characters, write them with the issue number. I use square brackets around the issue number in GitLab just to provide that traceability to the issue. Keep branches clean, pull regularly from the remote to locally so you don't get out of sync. Regularly pull in updates, have that traceability to issues, and commit frequently. Commit your changes frequently, at least once a day, as a record of your work, and also just have a copy of your work just in case something locally was lost. Personally, I would recommend committing twice a day if you're working with code all day during your working day. So in summary then, we have seen the initial Git commands. We've seen an amazing Git cloud system, GitLab. As I say, GitHub is very similar. My preference, as you probably can tell by now, is GitLab. But all these things you can do in GitHub as well. We've learnt the basic Git workflows. We've seen VS Code editor. We've seen Git Bash. We've seen a couple of ways we can do it. We've seen the GitLab cloud. We've seen the traceability of issues to code, to branches, reviewing merges. We've seen applying code reviews in GitLab and applying suggestions, which then automatically translate to commits. And we've also done amazing things like Git cherry pick. We've rebased our code when the head has moved on from the head of our branch. And we've also used Git log and various options to explore the repository data. And we've also used the Git graph feature both in VS Code and in GitLab in this particular case. And then today we've built on what we did in lecture 1 by looking at those advanced commands and tool integrations and hopefully we've presented a viable workflow for you to use Git in your projects. And again, my encouragement would be create all of your tasks as issues. There are other things you can do in GitLab, for example, not just with code, but also with your commits here, you've got branches, you've got the repository, but you can manage tasks, you can create tasks. When you have issues here, you can also arrange them into sprints. And if I just go back to the maths library here, you'll be able to see with my issues that I can create these issues in bulk. So I can do bulk edit, bulk creation of new issues. And I can also manage them in sprints and organize in swim lanes. That's a topic for outside of this discussion. You can use Jira together with Git, but personally I would do everything in GitLab. So I'll store your requirements as issues. You can store test cases easily in GitLab. You can store your test designs in GitLab through Markdown. I would put all the project documentation as Markdown and all your test cases. You've probably heard of this trend: infrastructure as code, tests as code, documentation as code. Everything is kind of code, and GitLab really supports that workflow, as does GitHub. So I hope that helps. Let's just wrap up the lecture. Any questions you have on this, if you want to deeper dive on any of these commands, then go for it. Talk to me or John or the tutorial team. Post your questions on Moodle as well. Would love to hear your feedback on this session. We're addressing the feedback from the optional, from the responses that the evaluation units we received at semester 1, where there was a general request for more technical demonstrations of workflows and things like Git and DevOps and Kubernetes and Docker, those kind of technologies. So we'll do a few more videos like this to hopefully give you a record, give you some experience of using these tools that you can then apply to your own projects. So do post any questions on Moodle and also any comments that you might have. So that concludes our session on Git for now. We may come back to some more topics depending on questions, as we say. Thank you very much, and we look forward to seeing you next time.